It is January 23rd, 2026. Lava is advancing down Mayon slopes, while ash and steam plumes climb about 100 meters into the sky. This is a volcano emergency. Down below, more than 4,000 evacuees are jammed into 13 shelters that are already overflowing. They cannot go home, and nobody can tell them when they will be able to. You can hear it. Crying kids, coughing grandparents, plastic bags rustling as families guard the few things they grabbed on the way out. And here is the part that keeps me up. The danger is not only what you see or what happens next. The summit dome keeps shedding hot rock, and one larger collapse can flip this from slow to lethal in minutes. So what is Mayon really building toward? I'm watching Mayon, and it's the kind of beauty that makes my stomach drop. Mayon sits in Albay province in the Philippines Bicol region, and its cone is so perfect it's a logo. And that's the trap. But that geometry is exactly why it kills. Mayon rises about 2,462 meters, and its slopes are steep and smooth, like a ski run for fire. When a lava dome piles up at the summit, it doesn't ooze gently, it stacks, cracks, and collapses. And on a cone this steep, collapses don't crawl, they accelerate. That is why officials keep Mayon at alert level 3. A hazardous eruption is possible, and the danger is not only at the crater, it is everything that can rush down the channels. There is a 6-kilometer permanent danger zone around the summit for a reason. In 1814, Mayon's eruption buried the town of Cagsua and killed around 1,200 people. The church ruins still stand as a warning, so when you hear the phrase lava advance, do not picture a slow river. Picture a mountain built to turn one collapse into a race you cannot win. Think with me for a second, because Mayon's danger right now is not a vibe, it is a data set. On the January 23rd, 2026 update, PHIVOLCS reports that Mayon has had episodic mild magmatic eruptions since January 21st, 2026. That means magma is actively involved, not just steam. At the summit, a lava dome is being supplied, and a lava flow is being fed down slope. There are minor strombolian bursts popping at the crater. The plume headlines sound small, about 100 meters high, but the ground signals are the part that matters. In the last 72 hours, monitors logged 598 volcanic earthquakes. Not one dramatic movie quake, but constant internal movement, magma, gas, and rock adjusting under pressure. In that same window, there were 814 rockfall events, meaning hot material is repeatedly breaking loose from the summit area, and 230 pyroclastic density currents, those fast, ground-hugging surges that form when hot debris collapses and avalanches through gullies. Now layer in the gas window. In the last 24 hours, sulfur dioxide output was reported at 3,059 metric tons per day. Sulfur dioxide is one of the clearest clues that magma is rising and degassing. When that number is high, it can mean a lot of fresh gas is escaping. When it drops suddenly, it can also be bad, because it can mean gas is getting trapped. This is why monitoring matters. Seismometers catch every crack, cameras track crater glow, gas sensors measure emissions, and GPS and tilt instruments watch the cone subtly swell or relax. Scientists can see the trend lines. What they can't do is schedule the exact minute a stable-looking dome turns into a runaway collapse. So what is the mechanism tying these together? A viscous lava dome grows like a heavy plug. It cools on the outside, fractures, and sheds incandescent chunks. Each shed can trigger a rockfall. Some failures transform into pyroclastic density currents. And because Mayon is steep and symmetrical, gravity turns those failures into speed. Add the longer trend volcanologists have flagged deformation and inflation since June 2024, and you get the uncomfortable picture. The cone is being pushed from below while unstable mass keeps stacking at the top. Here is why that is forcing the evacuation to stay tight. A lava flow can look slow from a distance. A 100-meter plume can look minor on a chart. But pyroclastic density currents do not care how it looks on camera. If you are inside the wrong gully or too close to the summit when a bigger chunk lets go, warning time can be minutes or less. That is why alert level 3 matters, and why the 6-kilometer permanent danger zone is not negotiable. And it explains the human reality. 4,000 plus people are not in shelters because officials love evacuations. They are there because shelters overflow, schools get disrupted, and the one thing nobody can promise is the exact moment the summit lava dome stops shedding pieces and starts failing all at once. I keep thinking about what overflowing actually means right now. It is not just a number on a dashboard. It is a gym floor where families draw invisible borders with backpacks. It is a mother folding a blanket into her third so 2 kids can share it. It is a father staring at his phone, refreshing updates because the mountain decides the schedule now. More than 4,000 people are displaced and 13 shelters are packed past capacity, so sleep turns into shifts, privacy disappears, coughs echo, tempers spike, then drop because everyone is tired in the same way. Outside those shelter walls, life is paused in the worst possible place. A farmer cannot check his crops, a store owner cannot open. Kids miss school again because the danger zone is not a line you can negotiate. Even if the lava looks slow from far away, the threat is fast, where it counts. This is how disasters stretch, not one dramatic moment, but days of waiting. The dome keeps building, and every rumble makes people flinch. Now the question is, what happens next? Best case, the dome supply slows, earthquake counts ease, and pyroclastic density currents become fewer and shorter. Lava still advances, but the system starts relaxing instead of tightening. If that trend holds, officials can start phased returns only when channels remain quiet and rain is not priming lahars. But even in that best case, the 6-kilometre zone stays locked because one fresh crack can restart collapses without warning. Likely case, the siege. The dome keeps stacking and crumbling in cycles, rockfalls stay high, pyroclastic density currents keep pulsing down the usual gullies, and shelter life drags on for weeks or months. This is where fatigue gets people hurt, because the pressure to go home rises faster than the risk drops. That is why authorities keep troops and checkpoints in place, because the most common time people get caught is the moment they think it is calming down. Worst case, a larger dome failure. One big section lets go, and a dense surge runs farther than expected, with warning time measured in minutes. Ashfall thickens, roads go slick, and if heavy rain hits, lahars turn river valleys into moving slurry. So what do I watch for next? Not one clip, but patterns. Sustained tremor, faster deformation, sharp sulfur dioxide shifts, and pyroclastic density currents travelling farther or lasting longer. That's when active becomes escalating.